Artists, have you ever mixed two paints, expecting a vibrant result, only to end up with a dull and muddy mixture? In this video, we'll explore the secret structure of the color space, how the coordinates of the two pigments you're trying to mix matter, and how the pigment's opacity or transparency influences the mixture result. In a recent video by Doug Weaver, he showed us a fantastic diagram. Doug proposed the existence of these boundaries in the color space, lines which, if your pigment mixtures cross them, the result is muddy or lower in chroma. That video has since been taken down, but that particular concept is worth exploring further. Take a look at this color wheel. It was created by the late, great Merv Moriarty and his wife, Prue Acton, in Australia. Those boundaries Doug was talking about are marked on this wheel at ideal yellow, ideal magenta, and ideal cyan. And the overlay shows us mixture predictions in two different ways. First, you could start here and then choose your mixing partner. Then, depending on the ratio between the two pigments, you end up somewhere along this path. It works pretty good at generally predicting how much chroma you will lose based on how far apart the two pigments are in hue. But it comes with this other path for mixing vivid colors. And it says here, mix pure hues using pathway AB within a section. In other words, don't cross the boundaries. Then your mixture will not fall along this line, which bends outwards, maintaining chroma. Instead, it will bend inward, losing chroma. Note that the best cyan we have, phthalo blue, and the best magenta we have, quinacridone, would require us to cross the ideal magenta boundary. So we can't predict their mix with the AB line. Instead, we see that the resulting mixtures are predicted to lose some chroma, but we do better than if we tried mixing cadmium red and phthalo blue. Then we end up in the grayish zone. But there's another crucial factor influencing whether pigments will lose chroma when you mix them. It's related to their transparency. Most people learn that paint mixing is subtractive mixing, but strictly speaking, it's a compromise between optical mixing and subtractive mixing. And the more transparent a pigment is, the more it mixes with subtractive behavior. Subtraction in this context means subtraction of light. More light is getting absorbed. So opposing transparent pigments, when mixed, cancel each other's reflection. This one absorbs what that one reflects, that one absorbs what that one reflects. And so their mixture tends toward black. But opposing opaque pigments, when mixed, tend to average their appearance and therefore tend toward gray. Within a zone, two transparent pigments aren't going to cancel as much, so their mixture path bends outward, in other words, maintains chroma. Their mixture remains vivid. So if we combine these two ideas, the idea of these boundaries and of the influence of transparency on path curvature, we get a fuller picture of how your pigment choices affect the range or gamut of colors you can mix.